everyone, welcome to Unit 7. We are going to talk about quadratics. All right, so this is Lesson 1, Quadratic Basics. So the first thing, let's make sure we know what a quadratic is. And I already have it in here as far as the definition. Quadratic is a math expression of degree 2, which means that the highest exponent of x would be 2. In standard form, you will see standard form of a quadratic in a few different ways. Okay, you could see it as I don't know if I can type it in there. Let me just draw it in there. You would see it as, say, ax squared plus bx plus c. You could see it as, let's see, y. Okay, this would be an equation. Y equals ax squared plus bx plus c. You could see it as f of x is in function notation equals ax squared plus bx plus c. All of those are in standard form. Okay, so some examples of a quadratic would be these. Say we had, 3x squared plus 2x plus 4. That would be an example of a quadratic. Or you could have y equals a negative 7x squared plus 2x minus 8. Okay. So if I give you an example, I want to give you a non-example. So let's do that. So a non-example would be x to the third power plus 3. So what makes that a non-example is this third power. That's not a degree of the highest exponent of x is not a 2, it's a 3. That's what makes it a non-example. It means it's not a quadratic. Okay. So then you could also have 3x minus 4 would be a non-example because the highest power of x is a 1. Remember, there's a 1 there. Even though it's not written, there is 1 there. Okay? So then we also need to know what quadratic graphs look like. Okay? So we know that, okay, that's not right. All right. We know that a quadratic is a parabola. Okay, it looks like a parabola. So a positive parabola looks like this. Okay, went ahead and had this written on there. Yours doesn't have a graph on there. Your page doesn't, but you can draw that on there. Okay, all right. And a negative parabola is upside down, right? Okay, so let's describe these. All right, so a positive parabola, I'm just going to type this information in here. Positive parabola is, we could say it's smiling. We know that it opens upward. And the x squared term, the x squared y'all know it takes me a minute. X squared I thought I was going to be swift here, didn't I? The x squared term and it's everywhere, isn't it? It's positive. Okay. just a little bit smaller. I'm overzealous in that size there. All right. All right, so that's some attributes of, or that's a description of a positive parabola. Okay, so if a positive parabola looks like it's smiling, what does a negative parabola look like it's doing? Okay, so it looks like it is so it looks like it is frowning. It opens downward. So if the positive parabola has an x term that is positive, x squared term that's positive, a negative parabola has where the x squared term is negative. So anytime you see a negative x squared term, you should know that your parabola is going to be upside down. It's going to be frowning. All right. So we have some steps to solve quadratics. Okay. So solving by factoring, first thing we're going to do is put it in standard form. All right, and then we're going to factor, set each factor to 0. And then we're going to solve each equation. Okay, so let's do that real quick. All right, so first of all, we have to look and say, is this in standard form? Well, we said that standard form was ax squared plus bx plus c. So is my x squared term first? Yes. Is my b x term second? Yes. And then my constant is last. So it is already there. So this is already done. So now we need to factor. And we use t-chart factoring to do that. So x times x gives me x squared. I need my factors of 12. So 1 and 12. 2 and 6, and 3 and 4. And then I add those together to see which one is my winner. And we know that 3 plus 4 gives me the 7, right? All right, so my factors of this are x. Remember, my x's go in the front. X's go in the front here. This is a positive 3, and this is a positive 4, right? All right, okay, so now I need to set each factor to 0. So I'm going to set x plus 3 equal to 0 and solve that equation. Subtract 3 from both sides. X is equal to negative 3. Then I'm going to set x plus 4 equal to 0. And then I'm going to solve that equation. Move this down just a minute. So this is x is equal to a negative 4. So my two solutions are x is equal to negative 3, x is equal to negative 4. Not too bad, right? All right. Okay, if you notice, I left for just a minute so that I could get my calculator software up. And you are going to need your calculator, so get it ready. All right, so now we're going to solve by graphing. So the first step is we need to make sure we put it in standard form. So you're going to really need to know what standard form is. So make sure you're working on that. And then you're going to type the quadratic into a graph page. Notice I already have my graph page up here. And then you need to find where the graph hits the x-axis. All right, and these are the steps to do that below this. Okay, so I'm going to change this and make it another color. To do that, you do Menu, Analyze, Analyze graph, I'm pretty sure. And then 0, because you remember 0 is on the x-axis. Those are your zeros. Right, so let's do this real quick. Oh my gosh, is this in standard form? It is not, so let's do that. Let's put it in standard form. So we have x squared minus 5x equals 14. So we need to subtract 14 from both sides, right? All right, so I'm going to put this as x squared minus 5x, and then I had to subtract 14 from both sides, so minus 14, and that equals 0. Okay, so I'm good with that. All right, so I've done number 1, and now I need to type this into the graph page. So I'm already over here, so I just need to type this in. So I'm going to do x squared minus 5x. Make sure you're using the minus, not this negative right here. And then minus 14, and then hit enter. Okay. So I'll pull that out of the way, and you can do that too. All right, so we need to find where the graph hits the x-axis. Well, we can see it right here and here, but we're going to use our calculator so it actually tells us what it is, okay? We have to do it 2 times, okay? So whenever I do this, I call this click, drag, click, okay? So I'm just going to put an arrow here, and I'm going to call it click, drag, click. All right, and we're going to do menu, analyze graph, and then 0. Okay, and notice I have this vertical line. I'm going to click, drag it across where it touches the x-axis, and click again. There's one of my zeros. Have to do that again. All right, you have to do it twice, both of them. Menu, analyze graph, 0, click, drag, click. All right. So this is where it is, okay? So I have, it crosses over here at -2, there's -1, -2, there's one of them, then it crosses over here at 7. Let's see, 1, 2, 3, 4, 5, 6, 7. There's one of them. This is what my graph looks like. Because if I ask you to sketch it, you better have those little spots right there. They better be marked right here. This is at -2, 0, and this is at 7, 0, okay? So this right here is a solution, and this is a solution. All right, they're also zeros. Okay, so this solution is x equals -2, and this is x equals 7. Both of those are solutions, okay? All right, that's it. Make sure you're looking at this when you're doing your assignment for lesson 1, because that is a quiz grade, y'all. All right, watch your spelling. Have a great day.